Lesson 8.3, Conditional Probability. Conditional probability is the probability that event B occurs given that A has already occurred, and we write it this way. So this is the probability of event B given, the line, vertical line means given A happened. So A already happened. So what's the probability that B happens after A has already happened? So let's say a family has 3 rabbits and 1 guinea pig. They randomly select a pet to get brushed and then randomly select a different pet to get a treat. Find the probability they select a rabbit to get a treat given that they selected a guinea pig to get brushed. Well, let's start with a sample space. So our sample space is everything that could happen. So rabbit 1 could get brushed and rabbit 2 get the treat. Or rabbit 1 could get brushed and rabbit 3 could get the treat. Or rabbit 1 could get brushed and the guinea pig could get the treat. Or maybe rabbit 2 brushed and rabbit 1 treat. Rabbit 2 brushed or rabbit 3 treat. Or rabbit 2 brushed, guinea pig treat. Or rabbit 3 brushed and rabbit 1 treat. Rabbit 3 brushed, rabbit 2 treat. Or rabbit 3 brushed and the guinea pig got a treat. Or maybe the guinea pig got brushed and rabbit 1 the treat. Guinea pig got brushed or rabbit 2 the treat. Or the guinea pig got brushed and rabbit 3 got the treat. Now remember, they said it's a different pet that gets the treat, so we don't have guinea pig brushed and guinea pig got treat. Alright, so we want the probability that they select a rabbit to get the treat, so a rabbit, given that they selected the guinea pig to get brushed. So the guinea pig was brushed, the rabbit gets a treat. So in our sample space, which ones did the guinea pig get brushed? Well, those. So that appears to be 3 options out of, how many total do we have? 12. So that's 1 out of 4, or 0.25. Why don't you pause this and try number 1. For number 1, you have 2 veggies over 4 options, which gives you 0.5. A quality control inspector checks for defective parts at a factory. The two-way table shows the results. Find each probability. Okay, what's the probability that they pass given that it's defective? So we know it's defective, but we want to pass. So we're going to look for defective but still pass. That one right there. So that's how many pass that were defective out of, what's our total? Well, our total is that it was defective. So how many total defectives do we have? 5 plus the 24. So we have 5 that passed that were defective over all our, so it's given that they were defective, so we can only have it over our defectives, or 5 over 29, which is about 0.172. It's not very high, but it's probably higher than the company would like. Let's try another one. What's the probability that it passes given that it's not defective? All right, so we want to look at the non-defective. The passing ones are the 208. And the total is the non-defective because we're given that it's not defective. So we're only going to compare it to the not defective. So it'll be 208 to 217, or about 0.959. Why don't you pause this video and try number 3. The first part you should have gotten about 0.875, and the second part you should have gotten about 0.48. All right, another way you could calculate the conditional probability is using this little formula. So the probability that B occurs, given that A already occurred, is the probability that both A and B occur at the same time over the probability that just A occurs. So let's find the probability that we pass given that it's not defective using the formula. All right, so that would be equal to the probability that it passes and is non-defective over the probability, says the probability of A. So that's a thing that we're given. So in this case, not defective. All right, so pass and non-defective would be that one. 208 over, well, what's our total? Our total is, if I add them all together, 246. Divided by the probability that it's non-defective. Non-defective would be 208 plus 9 over the 246. Well, that's about 0.846 on top and 0.882 on bottom. When I divide those, I get 0.959, which is the same thing we got before. So you do the probability for the top, the probability for the bottom, and those probabilities are divided by the totals, and then divide those. Why don't you pause this and try number 5. Let's try another example. At a clothing store, 75% of customers buy a pair of pants. 24% of customers buy a belt, and 20% of customers buy a pair of pants and a belt. What's the probability that a customer who buys a pair of pants also buys a belt? All right, so we want the probability that we get a belt given that they bought pants. That's the probability that the customer who buys it, we know they buy a pair of pants. And then we want the probability to get the belt also. So that would be the probability of a belt and a pant over the probability of just the pants. All right, well, belts and pants. Belts and pants. This one was pants. This one was belts. This one was belt and pants. So that'd be 0.2 on the top, and the pants is 0.75, which gives us 0.267. Let's try another one. What's the probability a customer who buys a belt also buys a pair of pants? All right, so this one is the other way around. We're given that we buy a belt, so we want pants given that we got a belt. So this is the pants given that we already have the belt. So the top would be pants and belt. The bottom would be just the belt. All right, pants and belt, that was the 20% or 0.2. And just the belt is the 24% or 0.24. When you divide those, you get 0.833. More likely to get a pair of pants if you buy a belt than if you get a pair of pants and then buy the belt. Why don't you pause this and try number 9. The answer to the first part should be 0.535. The answer to the second part should be 0.479. Well, let's say an airline company strives not to lose luggage. We hope. A manager is evaluating 3 flights in order to determine which flight loses luggage the least often. At the end of each day, the manager records whether or not luggage was lost on the flights that day. The table shows the results. Which flight loses luggage the least often? All right, so what we're going to do is we're going to make a two-way table to show the joint and marginal relative frequencies. All right, so let's see if we can get it in here. So we have lost, not lost, and a total. And then we're going to have flight A, flight B, flight C, and a total. All right, so flight A. There are a total of, if you count them, 40 total marks. So A lost was 10 over 40, or 0.250. The not lost would be 3 over 40, or 0.075, which gives us a total for A of 0.325 if I add those together. For flight B, there's 9 over 40 for lost, which is 0.225. For not lost, there's 5 over 40, which is 0.125. Add those together, you get 0.350. For flight C, lost is 12 over 40, which is 0.300. Not lost is 1 out of 40, which is 0.025. You add those together, you get 0.325. If we add straight down, get 0.775 and 0.225. Wow, they lose luggage far more than they don't lose luggage. And the total is 1, which we would expect. All right, so now let's answer our question. We want to find out which flight loses luggage the least often. So the probability that it's not lost, given that it's flight A, would be the probability that it's A and not lost over the probability of A, because it's the second one. So A and not lost is 0.075. The probability of A is 0.325, which if I divide those, I get 0.231. All right, let's try flight B, that it's not lost given that we're on flight B. So that'd be the probability that we're on flight B and not lost over the probability that we're on flight B. All right, B and not lost is 0.125. Flight B is 0.350. Now you might say, hey, I could probably figure this out and see which one is the best just by looking at this chart. But what if you didn't have here we have about the same amount of data for each flight. But if we didn't, if they were very much different, then it'd be harder to tell. For flight C, we'd want the probability that the C and not lost. The probability at C. All right, C and not lost is 0.025, and probability of C is 0.325, which gives us 0.077. So which flight loses luggage the least often? Appears to be that one, which is flight C. Sorry, I interpreted that wrong. C has the smallest probability of not losing luggage. So we want the highest probability of not losing luggage. Highest probability of not losing luggage is actually flight B. Highest probability of not losing luggage is flight B. Why don't you try number 11? Pause it while you figure it out. The answer, again, is B.